Hello. I hope all of you are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft and I'm also an educator at Level. So in this video, let's quickly get started without wasting any time to talk about our very first aspect, which will be about process. Okay, so the moment we hear the word process, one of the common things that happens a lot is that students very easily get confused between what is a process and what is a program. Okay, because the word looks very similar and sometimes some people uses these words interchangeably as well. So what we're going to do is first we're going to break that misconception and talk in detail what exactly is a process and what exactly is a program. Okay, so whenever we talk about program is more or less like I would say, a executable file which contains a certain set of instructions which are written to perform a specific job. Okay, so program is like it's a executable file, a file which can be executed. It contains a particular instruction that needs to be performed to complete a specific task. Okay, for example, the moment you see chrome.exe, exe is executable. Okay, that's an executable file that contains the set of instructions using which you can view the web pages. Another example would be, let's say you have notes.notepad.exe. So again, it's an executable file which contains a set of instructions using which you can add, edit, or print the text files. Okay. Remember that the programs are not stored in your primary memory, okay, in your computer. They're actually stored on the disk or in your secondary memory, okay. But whenever we talk about process is basically a program in execution. So when you have a program, it's just an executable file. But when you are actually executing that file, then it gets converted into a process. So program is just like a passive executable file, but when it actually comes into an active state, the program comes in an active state. When you start executing it, then that is when it basically becomes a process. Okay, now the execution of a process must progress in a sequential manner. So you never basically execute a process out of sequence. The execution of process always happens step by step in a sequential fashion. Okay, to put it into very simple terms, whenever we write our computer programs, okay, in a text file, and when we execute this program, it becomes a process. Like I said as well, right? When there are a set of instructions in a file, it's basically a program. But when you start executing that program, it becomes a process. Okay, that process performs all the tasks which are mentioned in the program. Okay, so whenever a program is loaded into the memory, like I told you, by default, a program is present either in the disk or in the secondary memory. Whenever you load it into the primary memory for its execution, it becomes a process. And a process can further be divided into 4 parts over here. Okay, it can be called, the 4 sections it has is stack, heap, text, and data. Okay. So here, the 4 sections that we discussed are stack, heap, text, and data, right? These are all the 4 sections which are available. What all these 4 sections do? The first section is stack, okay? So the stack basically contains, okay, the temporary data. Stack, as you know, contains temporary data such as methods or what you call functions and local variable. Heap basically is used for dynamic memory allocation. Okay, and then comes the concept of text. Okay, text basically contains the current activity. What is the current task or the part of the program that you're executing, which is represented by program counter and the contents of processor register. So you have a lot of register as well over here. And the last one that you have is data. Okay. And what exactly is the data containing? It is containing all the global and the static variables. Okay. So this is what exactly we can say over here. The process is divided into 4 sections. Okay. Next, what we have is the concept of state of a process. So always remember, you have a program, you load that program into the memory, right? And then the program start executing and it basically becomes a process. So whenever the process is being executed, it always passes through multiple states. Okay, it starts with a state and then it basically goes from one state to another state until and unless it reaches the eventual completion or the final state. Okay, so whenever you create or whenever you take a program from your secondary memory to the primary memory, a new process is created. Okay, so it goes into the new state where the process is being created. Okay, after that, you go to the running state. So a process is said to be in a running state if it has CPU. Okay, so when you're running a process, you definitely require resources, right, to run the process. So whenever a process is running, right, it needs to have the CPU assigned to it. So when the process has the CPU assigned to it, it is in the running state. And at that point of time, since the CPU is assigned to that process, the process is actually using the resources of the CPU at that particular instance. So when you create the process, from creating the process, you go into a running state when the CPU is assigned to you and the process is actually being executed. Then you basically go to a blocked or the waiting state. Okay, so a process is said to be in a blocked or in a waiting state if it is waiting for some event to happen such that as an IO completion before it can be proceed. So sometimes what happens is the process is being executed. Okay, so you have written a program in which you require some input from the user, correct? It happens also, you usually write programs where you are expecting the user to give the input. So in that case, what happens is the process goes into a waiting state. Why? Because it is expecting an input output process to happen. And till the time that input output process does not happen, right, the process cannot move ahead. So currently, because of the way the program has been designed, where we expect some user input output and that process, and the user, since till the time it hasn't provided yet, the process goes into a waiting state. Okay, note that a process is unable to run until some external event happened. Okay, one of the ways how a process goes into waiting state is through an input output completion that is required. Okay, so till the time the external event will not happen, the process will not go back into the running state. Okay, after that, the process goes into a ready state. So a process is said to be in a ready state if it needs a CPU to execute. Okay, so sometimes what happens is you might run a process which may require CPU allocation, and sometimes it does not. So a process, if it does require a CPU allocation, then and when it is just about to require all that, then it is in a ready state. Okay, so remember, a ready state process is runnable. Okay, so you're ready to get some CPU allocation, and the moment you get that, you go into a running state. Okay, but sometimes it also happens that temporarily you stop because you have another process to run. So always you're working in an environment where multiple processes are trying to get hold of the CPU. So it may happen sometime that you got the CPU for some point of time and then it got allocated to some other process. So at this point of time, you are actually waiting for the process to get allocated back to you. And then you can say that that is one of the ready states where you are just waiting for the CPU to get allocated so that you can go back into the running state. Okay. And the last one is the terminated state. The terminated state is the one in which the process has actually finished execution. The process was executing in a sequential manner and all the tasks related to that process has been fully executed. Okay, so these are all the 5 states which are available for a process. So you have the new state, you have the running state, you have a waiting state or a blocked state, you have a ready state, and you have a terminated state. Okay. So this is more or less a more diagrammatical view of the states of a process. So you have a new process, that's a new state. From that, right, you basically become ready for the allocation of CPU. So you go into the ready state. After the process is created, it will go into the ready state. Okay. After that, once you have the CPU allocated to you, from the ready state, you go into the running state using this arrow. Okay, you can see. From the ready state, you go to the running state. Okay, let's say something happens because of which you have to halt the execution of the current process and some other process gets the CPU. So since you do not have the CPU allocated to you right now, you go back to the ready state. Okay, you are only in the running state when you have the CPU allocated to the particular process. If a CPU does not have this, if a process does not have a CPU allocated to it, it will go back to the ready state. Okay. And from a running state, right, it also may happen that you do require some event, to happen or some input output. So from the running state, you simply go into the waiting state as well. So from a running state, you can go to the ready state also, or you can go to the waiting state also. If some input output is required, you will go into the waiting state because you are waiting for the input output process to, or the execution to happen. And once it does happen, then you go back into the ready state, because the moment you go into waiting state, the CPU gets deallocated from you to someone else. So now to get the CPU again, you need to go back into the ready state. Okay. And the last one is the exit. That is when the entire process has basically happened, when all the sequential task of a process has been executed, then you simply go into the terminated state, knowing that the certain process has been completed, and then you can move ahead. Okay, so that is what pretty much the concept of processes is. Okay, so what all did we discuss? First, we talked about what a program is. So a program is nothing but an executable file which has a set of instructions, and when you execute those instructions, you complete a specific job. So a process or program basically is initially in the secondary memory. When you take that program, you load it into the primary memory for execution, it basically gets converted into a process. Okay, and process is basically a program in execution. Okay. And now a process has 4 components involved in it. It has the stack, which is used to keep the methods and the functions and the local variables. We have the heap, which is for dynamic memory allocation, such as for objects. Then we have the text, which basically contains information about the program counters, processor registers information, everything related to that. And then we also have data. Data basically contains the information about the global variable and the static variables. And then we started our discussion to talk about what are all the different states in a process. So whenever you load a program into the memory, convert it into a process, there are certain states that the process has to go through before it actually gets finally terminated or completed. What are all those 5 states? New state, where you're actually making or creating a process from the program. You have the running state. In the running state, the CPU is allocated to your process and it is being executed step by step. Blocked or waiting state. Waiting state is you are waiting for some external event or from some input output event to happen in order to get back to execution again. So in that blocking state, your process is not getting executed and it will stay in that state until some external event happens. From that, you go into the ready state. Now, the process is in ready state. That means the process has been created, but it is waiting for the CPU to get allocated to it. So it's temp, or sometimes you are in the running state and then you go back to the ready state because some higher priority process came up due to which it required the resources. So your current process basically got halted or temporarily stopped. And the terminated state is basically the state in which the process has finished its entire execution. Okay, that's what the terminated state is. And then we saw a quick program state diagram as well, wherein you are in the new state where the process is getting created. Then you go to the ready state where you're waiting for the CPU to get allocated. And the moment the CPU gets allocated, you go into the running state. While in the running state, two things can happen, or three things can happen rather. First is some external event is required. So you will go back into the waiting state and then you will get in the queue for the ready queue again. If sometime you are executing the process, right, and some other process basically got the CPU, then also you will go back to the ready state. And while executing the process, if all the states are completed, you basically terminate the process. So this is what exactly very basic information about what a process is. And I hope this is clear to everyone as well so far. In the next video now, we are going to talk about process control blocks. What are process control blocks? What are the different constituents or things involved in process control blocks, and how exactly we can perform the execution of it. Okay, so this is what pretty much we have right now for this first video. This was a very simple video because we need to move step by step for better understanding. And as we move to the next videos, we'll definitely scale our concept and scale our understanding to talk about these concepts in more detail and with a deeper understanding. So stay tuned for all these videos as well. Thank you.